Let's be honest now. This has been long overdue. Hello everyone and welcome to yet another science stream. Yeah, it's been a while since I've done a science stream, too long. I just genuinely forgot that I could make science streams. I genuinely forgot that was an option. Because really often when I was doing science streams, I always was doing them because, I was doing them because I had to do something else, and I thought, oh, science stream would be a fun way to do it, and I would learn something, you would learn something like that. But I genuinely forgot I could just do science streams. So, what do I have open? Oh, I have this open, by the way. Look at this. Give me a second, let me just check one thing. Alright, thing has been checked. Take a look at this. Yeah, oh, wait. I have to first share my Discord the fact that I'm streaming, which is MKT charity streams. Where that? Here it is. Let me just. Oh my goodness! I should be starting these streams prepared, shouldn't I? No, never. Unpreparedness to the end. Alright. Add stream. Long overdue indeed. So, first of all, we should all take a look and appreciate this, which is made by Tefta actually. You cannot see it by in top left corner. Oh, you can actually see it. Yes, made by Tefta. Tefta taught Stable Diffusion what I look like, and now I can just read stuff like these, which is pretty funny, not gonna lie. Most of them are, they are a bit special, most of them, but sometimes we get these pearls every now and then. For example, this, I never wore red. Like, this tells me I might look good in red. I like the idea of that. Those there. Yeah, sometimes they're a bit special, but there's a very well trained AI. I mean, look at this! Oh boy, I wish I had that sort of bow tie. It's a very well trained AI. I just cannot get enough of it. It's so funny. Like, this looks very decent. I feel like I should be rendering something for this in the meantime, because it's a really fun thing to render. Actually, I'm wondering what happens if I increase the CFG. What looks more like make it? Decrease CFG? Or, well, increase CFG should look more. Oh, goody, it's a green mask. That's already not what I was expecting. Yeah, I'm rendering with 100 sampling steps because might as well. The quality is really low, so might as well 100 sampling. That does not look like me, does it? Oh yeah, more like it. Yeah, I'm guessing it detects the green screen in the background, right? And just... yeah, I do have a lot of green screen in the background in my videos. Okay, so increased CFG might have overdid it ever so slightly. Today I suppose we could do some science normal stuff, like capacitors. I feel like capacitors might be a good way to do it. I should stop having fun with this. This is so much fun. This is too much fun. Alright, so decreased CFG actually looks better, around 5. That should be a sweet spot. I'm having too much fun with this. Surprisingly many of them have green mask, and surprisingly many of those green masks look good, actually. I mean, don't get me wrong, I do adore the OG white. I'm just saying the green don't look this bad. As bad as it could, at least. Alright then. Library texts. I'm pretty certain that's what it was. Yeah, and explore the libraries. It was engineering, I think. Decently certain. It was engineering, and electronic components, electric components. Good question. Might be this one of these. Fundamentals, basic series. Oh, this looks like the thing. Yeah, let's see. Because capacitors should be either 7th or 8th. Capacitors are 8th. This is this one. Okay, good. Great. So finally we are going to capacitors. Yeah, now this looks good. My goodness gracious me. That is quite up there. Let's get it up to 800, 800. Still doing squares because otherwise, well, 720 I suppose could work. I could increase the batch count, batch size a bit. We are doing 800, 800, 100 sampling steps, which means that batch count shouldn't really increase it that much. Right, it's batch count. Oh no, batch size, sorry, my mistake. Alrighty, it's been a while since I did anything with electronics, so this should be fun. I just can't. The AI is too good. All right, it's too. You know how funny it is when you can generate yourself. It's very funny. It's quite comical. Look at that. Oh yeah, I can totally use this for my Tinder profile. Now, capacity. Yeah, cool. I know what capacitors are. Okay. Stores energy. Yep. Capacitor can be a little more. But as this open circuit, DC current will not flow through capacitor. DC voltage, negative charge will build up. Is equal to voltage across capacitor is equal to that of voltage in the process. A certain amount of electric will be accumulated on plates. Okay. DC current will not flow through a capacitor, which means AC current will only flow, right? Because I'm guessing some sort of current should flow through a capacitor. Negative charge will build up on the bottom plate, while positive charge builds up on the top plate. This process will continue until the voltage across the capacitor is equal to that of the voltage source in the process. A certain amount of electric charge will have accumulated on the plates. The ability of this device to store charge with regard to the voltage appearing across it is called capacitance. Symbol C and has units of farads. Most of the time it's using microfarads, if I'm not mistaken. Microfaraday. Oh, it's after Faraday. I had no idea what was a thing. The electromagnet. By definition, total charge of 1 coulomb is associated with potential of 1 volt across the plates. Wait, capacitance is 1 farad. 1 coulomb. Hold on. It's 1 coulomb divided by 1 volt. Hold on now. Hold on. Q divided by V. Paint. I need my paint. Farads, right? 1 farad is equal to coulomb divided by volt, which means negative first, then inverse would be volt divided by coulomb. Let go amperes in relation to coulombs. There should be a B there. Ampere 1 ampere is equal to 1 coulomb 1 second, which means 1 ampere. Ampere, that would be coulomb per second, which means if we were to divide both sides, no wait, if we were to multiply both sides by a second, then what we would get second divided by farads is equal to volts divided by coulombs divided by seconds, which would give us seconds divided by coulombs is equal to volts divided by amperes. Which means I had no idea where I was going with that actually. I had some sort of idea, but no. More generally, C is capacitance in farads, Q is charge in coulombs, V is voltage in volts. If a total charge of 1 coulomb is associated with a potential of 1 volt, 1 farad. For any given voltage, the greater the capacitance, the greater the amount of charge can be stored. Okay, so the size capacitor, the greater the voltage, the greater the charge is stored. Amount of energy can be stored in the capacitor. Okay, so 1 microfarad, by the way, with 4 volts, if we multiply both sides by volts, then it's micro, but that's so convenient, which means that VC is equal to Q, right? This equation tells us how much charge could be stored in the capacitor then, which means that with 4 volts and let's say 20 microfarads, right, times 20 micro mini is 1000, micro is 1 millionth, right? Which means 20 to the negative 2 to the negative fifth, 2 times 10 to the negative fifth. I think, is that right? The 0 is 1, negative 1 is 10. Yeah, negative 5, great, is equal to Q, so over here we can do 10 to the 4 times 10 to the 0th. And if we multiply both together, we get how and what now? So 4 times 2, this, so that would be 8. Times 10 to the negative fifth is equal to Q, which, well, long story short, should be not a lot. 8 times 0.1, that would be 1, 2, 3, 4, 5. This would be negative first, negative second, negative third, negative fourth, negative fifth, which is equal to Q, which means we get 0.00008 amperes, or 80 microamperes. This is mu, right? Is mu is micro, right? I am good at science. Okay. Unsurprisingly, energy stored in capacitor is proportional to the capacitance. It's also proportional to the square of voltage across the capacitor, which makes sense, considering that, why is the 1/2 here? That looks like something from an integral or derivative or calculus in general. When you have x squared 1/2, it's a really good indication that there might be something with calculus going on. It's a really good way to detect that. If you have, x to the n 1 divided by n, because calculus likes that a lot. You can calculate for yourself by just taking derivatives of normal stuff. Now, how and what we doing? No, by normal stuff I mean x to the nth power. W is energy in joules, C is the capacitance in farads, V is voltage in volts, makes sense, alright. Basic capacitor to conducting plate separated by an insulator, hence over here we had air because it's a great insulator. Material can be or made from a variety of different materials such as plastic or ceramics, depicted in figure 8.2.2. For practical capacitors, the plates may be stacked alternately, or even made of foil and formed into a rolled tube, really often. However, it is constructed, the characteristics of the dielectric will play a major role in performance of the device, as we shall see. The electric. I'm tired, okay? In general, capacitance increases directly with plate area. Makes sense. A, and inversely with plate separation distance. D. Further, it is also proportional to a physical characteristic of dielectric, the permittivity. Thus, the capacitance is equal to. Okay. Makes sense. So this is a resistor. That's what it is. It's a resistor, actually. Wait, it is. Wait. It is a resistor. I just fucking love how the only component in existence is a resistor. That's it. Over here, this entire circuit, right? The capacitor is just the input, then some sort of resistor, and the output. Oh, that's great. If you remember, the equation for the resistor, for its resistance, was the general resistivity, which we'll call the tiny r, times the distance in d divided by the area. And over here, the permittivity, I'm guessing. Permittivity would mean the opposite of resistance here, right? Which means for the capacitor, we would have 1 divided by R. I'm guessing that's what permittivity. I mean, if I'm wrong, we can really quickly erase that. Times A divided by distance. So if you take a closer look, right? Over here. Can you see the similarity? So over here, let's use the E. Right, well, not E. Epsilon, I think. I'm not good with Greek. I'm barely decent with normal languages. I'm not that great with math languages because Greece isn't a real place. Let's be real. We all know that. Now, RDA. If we inverse that, we get E. We get DEA. But if E, well, not E, I'm just calling that E, would be equal to 1 divided by the resistivity, then over here would have D 1 divided by RA. And if I'm not mistaken, I hope I'm not. I don't think I am. Yeah, because this is A, yes, which means we can bring the R over here, which means we get RD divided by A, which is exactly the same equation. It's equal to the RD divided by A. Which means that if the permittivity, which I'm guessing, well, it sounds like the opposite of resistivity, right? If this is the opposite of the resistivity, that means the equation for a capacitor is exactly the same as the equation for a resistor, which is funny. Absolute permittivity, epsilon, I was correct. Good, feels good to be right for once. As a measure of electric polarizability of dielectric, tendency of matter when subjected to electric field to acquire electric dipole moment in proportion to that applied field. Okay, listen. Scientists love simple words, okay? You have to understand. Shall I play some music, by the way? Or is me just talking about very normal stuff enough? A material of hyperizes more in response to... it's not the same. It's similar, it's not the same, unfortunately. Oh, it would be so great if the equation for the capacitor would be the exact same as for the resistor. Polarizes more in response to an electric... Wait, it is the same. Thereby storing more energy in the material. More generally, permittivity is a function of state, depends on frequency, magnitude, direction, or SI permittivity is farad per meter. It is not. Because then meters per farad would be the resistivity, which don't make much sense. Alright. Should be known that the effective plate area is somewhat larger than the precise physical area of the plates due to... this is due to a phenomenon called... how does one pronounce a word like this? I use DuckDuckGo because I'm tired of solving captchas. Present participle fringe. No, it's great. That was exactly what I was looking for. Fringe, to fringe, border, and no.
Fringe.
Fringing. It's a fridge. It's a this is due to a phenomenon called a fridge. Essentially, the electric field lines bulge outward at the plate edges rather than the maintain uniform parallel orientation. Okay, this is a figure 822. That doesn't really matter to us. Very simple because it's kind of logical magic. That's what it is. Now. Precautions of permittivity of the dielectric plays a major role in determining volumetric efficiency of the capacitor. In other words, the amount of capacitance that can be packed into a given sized component. Makes sense considering it's literally 1/3 of the equation. Now, table, yes, a lot of stuff. If you'd like to know, here's the relative permittivity and the material, if you'd like. Very fun. Vacuum actually... Huh. This really looks like inverse resistivity, honestly. Really looks like it. Because calcium copper, yeah, that sounds like something that would be very non-resistive. At quick glance, might seem that choosing dielectric with highest permittivity would be best choice, but it's not necessarily the case. Yeah, I suppose. Yeah, so it's complex. That column me surprised. Unlike resistors, capacitors do not have maximum power dissipation rating. Instead, they have maximum voltage ratings. Okay. Breakdown strength measured in volts per unit distance. Thus, the closer the plates, the less voltage the capacitor can withstand. For example, having the plate distance doubles the capacitance, but also halves its voltage rating. Cool. Complexity illustration, for example, consider versus, yeah, a lot of words. I feel like, because voltage is the measure of how far electricity can arc in a given medium. I need you to elaborate on whenever you are joking right now, Tefta, or if you are serious, because if you are serious, then I have some real reading to catch up to. I was pretty certain that... No, serious. I must have read a different definition of voltage and now I'm actually terrified. What is voltage? Okay. I had it explained. Well, I haven't really heard it explained, I only read it, which might be the problem actually. An abstraction. Okay, yeah, well that, yeah, because you see, this is the definition I'm familiar with. You know the basic stuff, right? There's stuff like this. It's pretty basic. It's, you know, just just the default stuff, honestly, if you think about that. Yeah, it's very, very normal, very standard. That's some, just something that I'm familiar with. Anyway, let's carry on. For large capacitors, the capacitance value and voltage rating are usually printed directly on the case. That's convenient. Some capacitors use my phase then, which stands for microfarads. Yep, I guessed correctly. While a capacitor color code exists, rather like the resistor color code, it has generally fallen out of favor. I still don't know why we have resistance codes, honestly. I just don't really understand. If there is enough space on the resistors to print the values, I just don't understand why we choose to cover them in colors. It's so inconvenient. It works, it does work, but decoding it is so inconvenient because these colors are similar sometimes. Is it brown? Is it orange? Which shade of red is that? Is it gray or white? I'm pretty saying gray or white. The buttons, yeah, it's so annoying because it's unreadable. Resistor codes. Oh fudge! Now I remember why I used DuckDuckGo. Resistor color codes. DuckDuckGo does not discriminate against. Take control of your personal data. No, mate. Will block trackers trying to collect your data as you browse. Tempting, but no, unfortunately, no, it's good enough. Okay, over here, there is a distance between this one and this one, which is nowhere to be found on any resistor. On every resistor, or every single resistor I have, the distance between every single one of these is constant. Which wouldn't really matter if not for the fact that it's not mirrored. You have to read it from the correct place. That's the first. I could make a podcast just arguing why bands and resistor are. On the other hand, there's orange and brown, which look the same. There is gold and yellow, which look the same. There is blue and violet, which sometimes are different, but sometimes are the exact same thing because they choose the darkest shade of blue possible. Also, wouldn't it be easier to just cover the resistor? Because here's the thing: there are different kinds of resistors, right? And okay. Welcome to my TED Talk. Welcome to my TED Talk right now. Bulk electrical components. When you're buying, is this good? Resistors. When you are buying resistors in bulk, right? You have a couple of options, and you can buy, these normal standard looking resistors. But the truth is, when it comes to actual electrical stuff, like for normal resistors, you almost always buy these ones. At least not always, obviously. There's quite a lot of cases where you wouldn't buy these, but these are the ones you buy for. Electrical, not electrical. Yeah, electronical. I am good at words. These are the ones you buy for electrical stuff. These are the ones you buy for electronical stuff, because these ones can withstand a lot more juice. And on these, as you can see, there is no bands. It's just a block. So this isn't even uniform. This is not even a standard. Like, let's see how long it takes before we find a resistor with bands here. It's ridiculous. Okay, let's sip some water to calm me down. Alright. Happy place. Let's carry on. The first two digits are the precision portion, and third digit. Wait, how and what now? Microfarad as well. Capacitor color code exists. Like the resistor color code, it has generally fallen out of favor. For small capacitor, numeric code is used that echoes the color code. Typically, it consists of 3-digit numbers such as 152. First two digits are the precision portion, and the third digit is the power of 10 multiplier. My goodness, I like that. is picofarads. Oh, I like that so much. Oh, it's a 3D. Oh, I love that. Oh, yes. That's such a simple thing. Just take 2 digits and add the third digit number of zeros to it, and you get picofarad. Oh, that is wonderful. That is so pleasant. Oh, yes. If not for the fact that capacitors are hell on earth and almost impossible to use, then that would be great. Series and parallel. Oh, already in the first. This is the first page. No, the second page. But the first page we know was just kind of really basic. So on the first actual page, we already get capacitors in parallel. Do not behave the same as resistors. Obviously, no, that would be too easy. Placing capacitors in parallel increases overall plate area and thus increases the capacitor. Okay, so we can do the same trick as we did with resistors. Right? I mean, okay, wait. So, we can do the same trick. With resistors, if we increase the area, we decrease the resistance because of conductivity. Over here, if we increase the area, we increase the value, which means that if this is a capacitor with some sort of capacitance in, let's say 100 farads, right? This is one, it has 100 farads. It's a very powerful capacitor. Yeah, it's a very powerful capacitor. Then two capacitors in parallel, due to our little equation from up above, would double the area, right? But it would leave the distance the same, which means over here we would have 200 farads. So this is actually simple. All right, I think. Let's see. Plus the highest I've ever seen is 1 farad. Well, yeah, as I said, these are rather. I just assumed quite strong capacitors. How much is actually 100 farads? It's area distance. Well, okay. Let's see. What is we have a data sheet here. We can check what kind of capacitor would that be. Let's say we use silicon. Seems fairly normal, right? For silicon, let's say we use silicon, which is 1168. 1168 times area divided by distance. What kind of distance? Well, distance should be as small as possible. Let's say that we wouldn't be too crazy and we would just choose something like a millimeter, not smaller, which means, because this is in meters, I'm decently certain, 0.001, right? Which would mean 11 times 1,000. 11,680 times A would be equal to 100. Actually, it wouldn't be that much. It wouldn't be that massive if you use silicon. It would be alright massive. Right? We have to divide both sides by this, and unless I missed something in calculations, I might have missed something. But it shouldn't be that massive. It should be equal to, the area should be equal to 100 divided by 11,660, which is not a lot. It's 1/100th, something like that. Okay, so find the equivalent capacitance shown in the figure over here. Yes. Now we just add all of them together because capacitors are rather simple. Resistance is a bit more complex, like by definition a bit more complex, and I don't mean the complex as a synonym to hard. I mean complex as complex. It's just genuinely complex because resistance is an abstraction. I feel, okay, that felt like a douche thing to say. It's because I dislike it so much because all of these words, all of these scientific words sound tough, right? They sound as if I know what I'm doing, but they are simple. Because saying something like, Resistance is quite complex due to the abstraction. Sounds very scientific, but it's... Well, it is scientific, but it's not difficult to understand if it's explained correctly. I have to just make a video about this. I'll have to make a video about electronics, and that's it. That's it. Find the equivalent capacitance of the network shown in figure 8.2.10. Okay, so we have... They go both ways, so that's... Shouldn't be hard. It should be really simple. Wait, what happens... Wait, so we always add them together if they are in series and in parallel? We just always add them together. Wait, is that really it? Well, this will be difficult then. That'll be 24. No, obviously we don't. Wait, so parallel are simple, but left, yes, we get 8 for this, exactly. And then total, capacitance of left and middle capacitors are in parallel. Capacitor to the right, yeah, exactly. Oh, so it's the other way around. Oh, so it's opposite, actually, to what resistors do. Because here's what resistors do. When it comes to resistors, if you have them in series, you just sum them, right? This is the first resistor, this is the second. Then the total resistance, right? Actually, the other way around. Total resistance would be equal to 1 plus 2. Or actually, resistor 1 plus resistor 2. If they are in parallel, like this, right, 1 and 2, then the way we do it is 1 total resistance, right, is equal to 1 divided by 1 divided by resistance 1 plus 1 divided by resistance 2. Everything is inverse and messed up and stuff like that. When it comes to capacitors though, this would be just adding capacitors, capacitor 1 plus capacitor 2, but this would be the inverses, which actually makes a lot of sense, because from what we've seen already on the beginning of the stream, I should recap on that, on the calculations I made, over here, this is the equation which tells us the resistance of a given resistor. It is the resistivity times distance, which means the more resistive the material is, the higher resistance, makes sense, and the longer the distance, right, the longer the resistor, the higher the resistance, also makes sense. Now, the bigger the area, the smaller the resistance, because I know, just go back a couple of streams where I explained it for the first time. Anyway, for the capacitors, it is the inverse, because we have, instead of resistivity, we have the permittivity, decently certain, denoted by epsilon, and area is on top, distance on the bottom, so they are switched. So this entire equation is basically turned over on its head. It is the inverse. Which would mean that this equation should be equal to this equation if we, like, you know, if we just ignore a couple minor details, you know, just like bat an eye on a couple of stuff, you know, just don't mind a couple finer problems, then we can say that this will be the inverse. They used to say buffer was the biggest when I was young, and now they just, to reduce, you can create, they just put dielectric to reduce and can easily create higher farad capacitors. What is the highest farad capacitor? Because I still remember when the farad capacitor was massive. Okay, I don't mean to go all YouTuber on you, but what is the world's biggest capacitors you can buy? Because I don't mean the scientific one. Scientists are crazy. They'll just build something just to say that we built something that has, I don't know, 7 peta capacitors, whatever. You can buy. So, like a relatively normal one. What was it like for, I don't know, $100? What can you... Oh, oh boy. Size of plates by using dielectric supercapacitors. Yeah, that's not like something that they would do. Oh, I have this open. I'm an idiot. Capacitors. What's the biggest choice here? Because the resistance is really easy to increase, right? Just air. Air by itself is... The resistance of air is just insane. So resistance is easy to increase. Capacitance, not so much. Capacitance is a bit more difficult. Microfarads. Really? Those are the only options? Oh, you are not... Oh, no, wait. I see all. Okay. Those are the only options. Oh, come on now. Really? You don't even have 1 farad here. And add all of them in parallel, maybe build something. Okay. So then by that logic, this should be 8. Wait. 1 divided by 1 divided by 8 plus 1 divided by 16, which should be equal to... Multiply this by 2, we get 1 divided by 2 sixteenths plus 1 16, which gives us 3 sixteenths, which gives us 16 thirds. Which gives us 5 point something. 5 point something. 533, exactly, 5 point something. Okay, so that is actually very simple. Yes, okay, neat, I like it. This. Oh boy, this wolf indeed. Okay, 1 divided by 1 second plus 1/4 plus 1/8, which would give us 1 divided by 4 plus 2 plus 1, which gives us 7/8, which should then invest, which means 8/7. 6,500 farads. Now with that you could build a really cool coil gun. Wait, oh wait, that you could actually use that wait. You could actually use that to build a coil gun. Oh my goodness. Oh, you could actually use that to build a coil gun. I'm pretty certain. Mate, I'm excited to build a coil gun. Come on, get me there. You could use that to build a coil gun. Oh my goodness. It's in bulk. Oh yes, you don't understand. You can use that to build a coil gun. Automotive military. Military? Do you have military grade capacitors? That would be funny. 5th column. 1, 2, 3, 4, 5. Thank you so much. Come on. Oh, that is... Oh my goodness. Apply. How much is it? Price. There is no price. It's priceless. Okay, let's go a bit lower, like 100 farads. Alright? Not so crazy, but still a bit crazy. Price per unit. It's $10, right? Okay. Discontinued. I don't... Okay, $10. Okay. For 100 farads. 2.7 voltage. That would be... Okay. So we could build a coil gun. Alright. I mean, I would have to dig into calculations to actually check it. And building a coil gun would actually be really complex. So maybe not yet. Only series only. Yeah, so okay, I was correct. So it's actually a very simple, easy process. Boy. I still haven't opened the bug. I started the stream. You didn't see that yet because on the very beginning, before I even posted on Discord, I started the stream by just admiring the AI. So great. I love the villain ones. For some reason I just love the villain. Hypervillain may be confusing it more than helping. I don't know why. It's my mask is really villainous. It's so much fun. Oh, this looks interesting. Oh no, my mask will be a bit funky in that one. I can already tell. Oh, at least I have 4 fingers. You can choose the best 40 images and use it to train a better one. Actually I could. Yeah, that's true. No train. How Hypernet. How and what? No. Okay, not yet. I might do it. But for now, the AI is already really good. If you put some good ones on Discord, I'll train it. I already have a lot of good. I mean, okay. Let me show you my folder for my favorite generators. Yeah, you joined for the science stream. No, this is not a science stream no more. This is okay. Make it the yeah, I did. I mean, this is so great. There are so many good ones here because most of them are rather, I would say, basic, but some of them are so good. Like for example the armed man, which I really. We have the armed man. We have the grin kit, which is the best mask generated I've had yet. The handsome make it, which I adore because if not for the fact that I already have an icon, I would use that as my profile pic. It's handsome make it is great. We have make it with a huge cock, which, well, yeah, human make it. This is 100% human make it. No one doubts that. This is human. We have make it player in space, which is actually very well made. That looks really good. We have the make it player, which is so amazing because for Markiplier's face is so recognizable, yet somehow the AI managed to create Markiplier without the face in a way that you can look at it and still see, oh yeah, this is Markiplier. I have this magic. Now I have a selfie, which is, I don't know. Oh, my personal favorite. So you haven't subscribed, huh? Which is make it sorcerer. Because obviously, why not? Make it work in a video. I love these. I just adore these so much. Alright, what else could there be? Pneumatic shot. Something will be fun. What will be fun? Tom Scott. It should know what Tom Scott. I'm pretty decently set. Let's increase the batch count to like 9. I'm a bit scared to increase the batch size. Maybe let's do 2 because, well, let's just say that these might be a bit more much. Like, I have a good graphics card, but you know, it's a good one. Some might call it great, and it is great for me, but not. Okay, determine the rate of oh, whoa! I might have skipped a bit too far. No, wait, we did this one. Voltage. Oh, voltage across capacitors. How do no? Yeah, this will generate in the background. I'll leave it be. Voltage source in parallel with a group of capacitors. The voltage will be the same across all capacitors, just as it's just a parallel circuit. If the circuit with multiple capacitors that are in series with a voltage source as shown here, the voltage will divide between them in inverse proportion. In other words, the larger the capacitance, the smaller the share applied voltage. Okay, understood. Which means that if we have a capacitor which has 8, 4 and a 2, then we'll have to divide amongst all of them the voltage, right? In a way so that, well, in an inverse proportion, which means that we'll have x eighth will go for the first one, x fourths will go for the second one, and x halves will go for the last one, so fourths and x halves. And we have to do it in such a way so that all of these... No, I messed it up, sorry. Pardon me, I messed it up really bad. X, which is the voltage of a circuit, would have to be equal to y divided by... No, wait. Determining the first, determining the series equivalent capacitance, the charge may then be determined using the applied voltage. Finally, voltage computed from equation Q is the total charge and C is the capacitance of entrance. Following example, nothing about the voltage source paragraph. Voltage will be same across all of capacitors. Voltage can also be found by determining the series equivalent capacitance. This is... I feel like this should be more of an explanation, less of an example here. Well, less of a task, I suppose. Total charge. Charge is constant across all of capacitors, therefore... Why is it constant? This is in series. And over here it says that series, the voltage will divide in inverse proportion. Oh, that is so smart, actually. Oh, because farads are... Because farads can be defined in relation to voltage. Obviously, I'm such an idiot. Alright. Where's the farads can be... dang it. What's the farad equation? Farad is Q divided by V. So if we have Q divided by V, what we do is we bring the V up top and we get QV is divided by Q, in which case we get V. Simple. So this Q divided by C is equal to voltage, obviously, which means that Q, which is... I think charge, like the Coulomb kind. Coulomb divided by volt, which means we have to get it in coulombs. And amperes are 1 coulomb a second, which means these are amperes times seconds. Yeah, this is not complex at all. This is very simple. Yeah, surely it is. Which means these are amperes times seconds. If you get an ampere, multiply it by a second, you get the coulomb. And over here, all we have to do is find the Q is equal VC, yes. Oh, you just take it and multiply it by... Oh, that's how you get total charge. I'm an idiot, obviously. You multiply by the amount of microfarads all of them have. Simple. There's a surprising amount of me when it comes to this AI. There's a surprising amount of me in the forest, which is weird considering that I don't really remember filming myself in the forest for any video. I mean, I did, but both videos for which I filmed myself in the forest weren't released. Well, one of them wasn't released, one of them isn't released yet. So I don't really understand. There's so many AI generated images of me in the forest. It's funky. Alright, so, okay, we have 12 volts. The total capacitance of the circuit is easy to calculate because it's just the inverse equation. It's 8/7. That's what it is, which means that we have 12 times 8/7, which gives us 80 plus 16, which gives us 96. 96/7. Yeah, we are calculating it exact. We are being exact right now, because this science, no silly tomfoolery here. 96/7, that's what we get when it comes to the Q. And now, for each and every single one of them, we have to get the Q divided by the farads, which basically means 96/7. Divided by, don't mind the x, divided by and every single one of these, which means we get 8, what microfarads, micro, I missed the micro, haven't I? This is micro, this is micro, this is U, all of them are U. Oh, but we divide U by U, oh, that's so convenient. Alright, so we have 8 microfarads, and we get this times this, 7 times 8, which is 56, right? 56, so we get 96 divided by 56 for the 8. Then for the 4 we get 96 divided by 28. Yes, and then for the 2 we get 96 divided by 14. Let's check our answers. Calculator. Which means we get, for the 8 we get 96 divided by 56. 17. Yep, we are just being more exact than necessary because we are cool. That's the reason. 3, 4, 2, yes, and 96 divided by 14, 6, 8, 5, 7. They have a mistake. See that? That's why we are cool, because we can actually say, they have a mistake here. They are 2 off on the end, which is inexcusable. 1 off is excusable, could be rounding or something like that, but 2 off, inexcusable. Practical tip: while maybe tempting to try, do not attempt to verify the in laboratory using standard DNM. Yeah, it's very tempting to try, to verify this in a laboratory, because I just have these capacitors laying around with it. I just have them laying around right next to the 12 voltage power source, which gives me exactly 12 volts. Yeah, I know, it's a very perfect voltage source, and a multimeter which just happens to measure everything perfectly. So I just have a laboratory, with my amazing I just bought it with my salary of $14 a month. It's living the life. So yep, resistance of digital many other electricity. As a result, charge will be transferred to the meter, ruining the measurement. Yep, I figured. Current voltage relationship. This is derivative. I knew it. I told you earlier on that when I even have it on my paint, when you see something like, do I have it? I hope I have it, because I don't have it. I erased it. Fudge. Well, basically we saw 1/2 times voltage squared, which is always a sign that calculus is involved. When you see x to the n divided by 1 to the n, that is a calculus badge. I is the current flowing through a capacitor. I, lowercase I. That's fair, I see this. C is the capacitance. dV dt is rate of change of capacitor voltage with respect to time. So the rate of change of voltage with respect to time is equal to the current flowing through a capacitor divided by the capacitance. Okay. Okay, I can see why that would be useful. The capacitor is fed a constant current source, the voltage will rise at a constant rate. Okay, if you say a good analogy is if we had a pipe pouring water into a tank, you probably imagine the pipe pouring water in some sort of container. I imagine a pipe, you know, pouring water into like a normal tank it can drive and stuff. Tank's level continuing to rise. This process is of depositing charge. This is for charging the capacitor. Yeah, I can see why it would be called charging the capacitor. Yeah, see current source. Yep. Okay, makes sense. Rate of change of voltage across the capacitor in the circuit in figure 8 to 15, which should be 5 divided by oh, this is a nano, which means we have 5,000 divided by 30, which means 500 divided by 3, which means what's 500 divided by 3? 166 negative because the ground is over here. Worth remembering. What in the Lord is that? Oh, I just had a really fun idea of what to do. This is, by the way, Tom Scott. This is not Tom Scott. I don't think the AI knows what Tom Scott is. I don't think Tom Scott got the cut. Markiplier did, but Tom Scott. Voltage across the capacitor cannot change instantaneously. Well, makes sense, but at the same time, tell this to the instantaneous rate of change. Cool. Okay, that's very cool. This is actually very cool. Very neat equation. Thomas Scott. What is Oh my goodness gracious me, that is my mask but a square. Again, this is the second time. Okay. I'm too much fun to say I cannot. Alright, but this is actually I really like this equation because you don't really see an equation like this often where the derivative is just equal to something. That is not really often the case. Initial and steady state analysis of RC circuits. No. Wait, capacitors can decharge, right? Oh, the sun is rising. Ah, that's fun. Capacitors can decharge, right? We haven't really seen a single thing about decharging capacitors. Because I'm pretty certain that's the big part of it. You can also decharge the capacitor, just like you can charge them. And the point is that they decharge quicker than charge most of the time, depending on how quick you charge, obviously. Because that's how you would be able to use capacitors. You would be able to charge them and then release a lot of charge all at once. At least that's how I plan using them in the coil gun, but you know, I suppose there are a couple of uses. They're also more boring ones than the coil gun. Just look like something on the microscope. Oh, never mind. Oh, never mind. Let me actually check. I'm impatient, I have to check already. Theory of operation. Sounds like it. Capacitor to conductors, yep, read it already. Capacitor farad. Capacitance farads. System unit, ratio, yup, farad, coulomb, volt. I only read the blue text because my brain is used to not paying that much attention. It's just, you do brain rot behavior, stuff like that. Contactors or planes comes together, allowing capacitor, practical devices. That's interesting. So you have two of them, two derivatives. Previous one was I divided by C is equal to voltage in relation to time. This one is charge in relation to voltage. And oh, what a coincidence, 100% coincidence. Yeah, that's what it is. I'm not gonna lie, I'm mostly waiting for this to finish. Well, image to image, no, I have not yet tried. I suppose I should. I wonder what happens if I take an image of make it and like image to image it to make it. I wonder what would happen then. I could try. I do have a couple of make it images. Algorithms, this. I do have this one. Very basic make it. This is just hide there, I'll make it. I should also wait for, wow! That is not me. I am way more shrimpy. Alright. How do we transform make it? Into what? Into what shall the make it be transformed? Actually, I have used image to image, but not on myself. So I should use it on myself, that would be funny. I wonder what will happen. I can demake it, make it. I know you already did that, but I can demake it, make it. Let's demake it, make it. I should probably wait for this because I don't want to get the CUDA out of memory error. Let's demake it, demake it. Get it? Demake it, demake it. It's funny. Alright. Ah, I just love him. Yeah, this is not really Tom Scott, is it? I just love this, the square. Oh. Oh no. Why are there so many square make-its? I will not comment on this one, no. Why are there so many square make-its? What's up with square make-it? Now that is a make-it, square make-it, there. Right, let's demake it. Let's see. Oh yeah, I probably should add human person. Because I just got turned into a bottle of something, a fluid. I like that. That is no realistic, if I may. It's different kind of person. That is nope. Okay, this just doesn't work. Let's just put it over here. I mean, kinda. Close. Face. Alright, demake it. That surely doesn't work. Let's make it to make it. We can make it to make it. That could work. Oh, I love how it turned the wall into my other room. Oh, that is wonderful. Make it squared. Yeah. What could be funny about make it? What could be funny? Make it performing magic. Make it the sorcerer. That could be funny. Make it. That is not magic. Let's take these. I really like these negative prompts. I stole them from Devda, and they just fix. Oh, that is very thumbnaily. If you get control net, makes this 10 times better. And what? Hi there, Ali. Don't mind. It's a normal electricity stream. Nothing weird going on here. Just normal electricity stuff. Boring good old capacitor stream and all the stuff like. Yep, nothing weird. Plugin for stable diffusion. I could look into that. Demaking the make it surely does not work, which means we have to make it. I love how it mesh. I also love how I have a knife in this one. I love how this is a very make it thing to do. Just hold the knife. Yes, exactly. All right, make it performing magic clearly does not work. What could work? Not a huge GTA fan. So yeah, I don't know. I was doing this more GTA. I'm very sorry for that. I won't in the future. Don't worry. I'm done. I'm done with GTA. No more GTA streams. Because apparently actually no one liked it. Okay, there was one person. I'm pretty sure Mr. Man liked it, but no. We need these streams to be more. We need these streams to be more fun. For more money. Don't be sorry if you enjoy it, dude. I mean, well, I enjoy doing stuff that other people enjoy. I myself am just a bot made to entertain people. I mean, a human who just likes entertaining people. These streams are like distract, make you while I try to rework. Okay, well, not really. I mean, if I'm not streaming, I'm doing stuff for YouTube, which hardly counts as real work. Okay. What could be fun? Like, make it in a real day job. I actually don't have to do image to image for this one. Image to image might be a bit difficult. Let's reduce the batch count and batch size for this to 1. 100 sampling steps though. This will be good looking make it. In a real day job, it's going to crush the AI. Okay, 100 sampling steps might be bit much for quick generations, I suppose. I love how it's struggling, by the way. Oh yeah. What's the update? How many videos are on the channel overall? Oh well, yeah, that happened. I forgot to mention. Oh yeah, did I mention that? Well, I didn't mention that, did I? I might have not. This is a very good song, by the way, Neve. It's a musical. It's a great one. You should go and see it. It's fantastic. I love Stipendium. Community. I might have. You see, Ali. There's this thing on the channel, and well, so basically, I did a thing. I did do a thing. You see, I realized something, and that is that I realized that YouTube is not a real job. Yeah, I had this realization for a while, but what I realized it means that I can actually, I don't actually have enough. There aren't any consequences. I have nothing to lose. So what I decided to do is to do a project which I wanted to do for quite a while. It's a skip. It's skip. That's skip. That's the. Bit too quick, mate. There's nothing here. Now you are over may be familiar with D Make It or Mr. Make It. The only thing I regret about this, I actually should wait till the end then, right? Now, here's the thing. This looks... Yeah, okay, yeah, here's the thing. This looks serious because the music is serious. Music was made by Tefta, which is 2 messages up in the chat. Thank you so much, Tefta, once again. But the thing is, the skip will not be as serious as this, okay? The skip is not... It's not serious. It's more about comedy. There's a lot more about comedy and less about heavy stuff. I just made the trailer look like this because it fit the music and it was actually pretty fun. It would be more of a because fuck it, why not, honestly. And also the additional scene, like it would look more like this. There always has to be someone who then cleans up their mess. They just die wherever they want. Yeah, that's the only thing I actually regret about this. The only thing I regret about the skip is that the audio is horrible. Super serious. Yeah, it's very serious. It's very serious. I think in the skip I die. How many times I die? I don't know. I should leave it for you to find out. No spoilers. No spoilers. I've managed to get it without spoilers for 2 weeks, so I'm not ruining this now. On Perfect Score. By the way, I'm not a narcissist, but oh my goodness, is YouTube recommending a lot of my stuff to me. Goodness gracious me. It's the only thing I regret is the sound, because the sound is very terrible for this. But on the other hand, I did what I could. When it comes to quality, when making videos, if you'd like quality, you just need money. There is no going around it. You just need money. You either need money to get yourself a studio or to get yourself some serious hardware. Because whilst, yes, there are many things you can do to master the sound, obviously, if you're recording in many different places, you need different kinds of hardware. Or key out manually the microphone, which is hell on earth, and not something that I am going to do for a very silly project. Seeing a pause that you have work in the big projects, do we have a drop date? The drop date is in 3 days. I am terrified. Did I mention that? That's why I've been streaming a lot of GTA, because I did not want to do any heavier streams. July 1st would, yeah. I didn't want to do any more heavy streams like this one, because I just wanted to spend like, I don't know, half an hour daily on streams, because I wanted to get back to working on stuff. So skip. This is a skip. It's a very dumb thing. It's not. Real day job. Make it working in a convenience store. If I could spell that correctly, that would be great. Yeah, no, I erased the wrong. Convenience. I'll get it at some point. Oh, so the first eye, it was the first eye, okay. And to catch up on the Make It lore, yeah, the Make It is very deep. Listen, there are layers to it. Like MatPat was thinking about making video, but decided to not because there was just too much lore. That was too much lore. Oh, I already love this image. The thing is, skip is a massive joke. That's what it was. Like, I was making skip to be funny, not to be serious, and the trailer just doesn't really do it justice, because I just had no idea how to do the trailer. Hopefully it'll be funny. I hope so. I have watched many of these, and I myself think they are really funny, and well, the funniest thing I've made this far. So I think that it would be pretty decent. I hate this. I cannot. I would love to tell you like many, I would also tell you the secrets about it, right, or the missing thing and stuff like that. But I can't. It's in 3 days. It'll be out in 3 days. I love this image. This is my future. It will be out in 3 days. I simply cannot. I love this image though. Let's bump it up. Let's bump it up to something that will be borderline not generatable. It really often generates multiple makers, which I'm pretty certain is a stable diffusion thing. Oh yeah, right. I forgot. Yeah, that's true. Emphasize the prompt. Yeah, now it would be more of a make it walking in the convenience store. I'm excited for this game though. I'm excited. The problem is that I haven't posted. Oh yeah, so the reason why I was so discombobulated when you mentioned how many videos is because I haven't actually uploaded anything for a while. For how long? 2 weeks, right? Well, 12 days, I think. We have only 500 videos. Yeah, 12 days. Exactly. Even shorts. I haven't even uploaded any shorts for so long. It's awful. Like my money is hurting me. It's just lack of money. You know, you have to believe me. I am a YouTuber, and I love money, right? So no, but it is a serious issue. What's this red? Closing parentheses detected. Oh my goodness gracious me, I cannot count. I'm not good with math. This way. There we go. The genuine issue, I really hate the fact that I do not have the hardware necessary. Because you can hear it in the videos. It's awful. It's just straight up awful. I dislike it so much. Abstraction of an example. Force is equal to acceleration. The sound over here is not as terrible because I have the Thai microphone.
And mass.
The issue with this is that this microphone is borrowed. I have borrowed it. It is not mine. Obviously, I can't afford it because this is actually quite expensive microphone. It doesn't look like it, but it's decently expensive, like $30, which is a lot. You can denoise in Adobe Audition. Yeah, but the noise isn't the noise isn't the problem that much. I became quite good at mastering sound during these past few days. Quite decent, I would say. And in Premiere, there's also an entire... Well, not a plugin, what's it called? Entire part of Premiere just dedicated to sound. The issue is that it's not that there's noise or rumble or something like that. It's just that there's no clarity. Like the Premiere cannot really fix it because there's nothing to fix. There's nothing to fix because the sound by itself is terrible. On the other hand, many people, when it comes to actual, sound masters, like for example Stupendium, you can see that, better scene with Honest Bob. You can see that Stupendium records sound in post, but to be fair, on the other hand, Stupendium does make songs, so that makes sense. And this clarity is just beautiful. I won't show it, if you can go watch it yourself. It's an amazing thing. I mean, how I can make it very tough. Yeah, that's a big issue. Because the thing is, it's not even that I don't have good hardware. It's mostly that I don't have specific hardware. Because when it comes to microphones, the issue is am I getting too technical for the stream, by the way? Like, if I start rambling, then just tell me in chat. Like, back to rambling. So, the issue is that there are thousands of different microphones, obviously. There are the Thai microphones, there are the shotgun microphone, which I'm using currently. So, when it comes to the microphones, many usages, right? Let's imagine we have the handy dandy, we have a make it clone, right? Which we would like to record. This is make it clone. The make it clone is just chilling here. It's chilling in, let's say, a room, right? Chilling in room. right? Don't mind the fact that the room is going the wrong way. It's just, let's just say it's a room. Yeah, make it clone is chilling in the room, and we would like to record the make it clone. How do we do it? Well, if make it clone is talking, then we would really like to give make it a recorder in their pocket, right? And get the tie microphone up to their tie. Handy dandy, make it wears ties, so convenient, right? Now make it, you can hear make it very well, except the issue is that this time microphone might be good, but if your recorder over here sucks because, I don't know, it's recording mono sound, then the whole audio will be terrible, because you see, when Make It is talking, you will hear the same sound in your left ear as your right ear, due to the fact that you are changing mono to stereo, which doesn't sound so bad. It sounds actually very minor technical issue, right? It does sound like it, except then
acts upon it to stop it or to move it in a different direction.
It sounds as if Make It in the basement. That is a big issue. Okay, this is not that big of a problem. Basically, point is, if the recorder sucks, then the audio is very compressed and is also very bland and very cheap. Like right now, you can hear me very well. That's because I am recording it on a good microphone, right? It's a good microphone, and the recording device is my PC. And because of that, the recording quality is just outstanding. I can post-process this right away. I am post-processing it with... you can use delay to mix very well. Yeah, I tried that, but this recorder is just not really great. Right now this sound is actually mastered. It is mastered, and I am going to break your world for a second, because you will be able to hear what it sounds like when it's not mastered. And are you ready? I would actually like to hear it for myself. Let me just... Okay. Let me just... Are you ready for me to break your world? Because obviously my voice is not that great. So in reality, it sounds like this, which is worse. Let's be real. Oh, I don't really hear it yet, but I already can tell it's whoopee. Yeah, it's worse, right? It's just terrible. That's why I use this post-processing on stream. Yeah, it breaks the magic, doesn't it? To learn that I actually tell it's a big difference. So this right now is the peak of the sound mastery, because I am using a good microphone, a good recorder, post-processing. It's great. When it comes to the videos though, it sucks. And it sucks the most when you don't have the time microphone, whoop, because you don't have the money, for one. They are learned that I'm deaf. Well, not really, it's just, listen, when you are stuck in a room and the only voice you can hear is yourself, talking about fucking C programming language or whatever else, I'm making a video, whatever, but yeah, right, then you start to go insane. Is that subtle enough? Okay, a hint of a difference. Yeah, it is a bit of a hint of a difference, but still, good microphone is up, right? But the issue is, when you don't have this time microphone, because, as I said, you don't have money for the hardware, then, and if you would like to record, make it in a scene where make it has like, I don't know, 3 meters to the left and let's say 5 meters to the right, then you have a bit of an issue. I'm not saying it happened, I'm just saying watch the skip, you'll see. Because then what you have to do is you have to get yourself a tripod, right? And you have to mount a microphone onto that tripod, and you have to use the shotgun microphone. Why the shotgun microphone? Well, it's because the shotgun microphone is specifically made to only pick up sounds from one place. Like, for example, from this. Which is really convenient, because then if the sound goes around the room, right, echoes from behind, then the microphone won't pick it up, which is great, right? It eliminates the echo. It's actually quite major. The only issue is that you see, this microphone was not made to pick up sound from like, I don't know, 7 meters. And because of that, the entire sound just sounds like it was recorded with a phone or something, and just sounds terrible. Case in point. Do I have a case in point? No, I don't count. There isn't a single video recorded that. Need Bob to hold the shotgun mic. Oh, I should build myself a bigger Bob. I should build myself a massive Bob to hold the microphone for me. Oh yes, I will build a bob. I will build a massive bob myself. What is this, by the way? That's not a convenience store. That's not a convenience store. That is. Or maybe it is. Okay, I'm not really used to going out or anything, but I'm pretty certain last time I went out, that's not what convenience stores look like. Oh, we can see our dear friend Square make it again. What? I don't think that's a convenience store. No. Doesn't seem like it. Apparently your mask is made out of the wall. It might be. This is actually very... I thought they are just glued onto the wall. Relatable. I think these brackets might be a bit too much make it for the AI. I feel like the normal amount of make it. No, this is too much make it. This is too much make it. Like, listen, we got to slow down. That's too much make it. You can't make it overdose. The point is, I'm just missing. Soon I'll be able to get a better mic. That has made it. No, but I will have one day something that will be called Madit, and so I am okay. I have dibs on this name. On Made It and Madit. I have dibs on those names. All right, I'm just saying. Cool dibs. I'm just so excited for the skip. It'll be fun, hopefully. I spent 2 weeks, so it better fucking be, alright? Unless I'm going to have a talk with HR Make It about the use of our human resources at Make It Incorporated. We need to have a talk. Yeah, I'm having so much fun, but I do know that I will have to end the stream soon. I'm not done with the skip. I've made, like, I've done 80% of the work for the skip, but I still have 20 to go. Yeah, I mean, let's, to be fair, I'm out of time. I've been out of time for this stream for like half an hour. Okay, I have how many days? I have 28th, 9th, and 30. I have 3 days. Each day it's like, well, each day I am awake for 24 minus 8 hours, which gives me 16 hours. This gives me 3 hours for resting, eating, and stuff like that, which gives me 13 hours of work. Each day, let's say 2 hours for stream, which gives me 11 hours of work a day. Tomorrow, wait, today, it's 28th, right? Yeah. Today I also have to spend 2 hours on normal work, not like imaginary, you know, normal working stuff. My funds, my savings are, we're running out of gas here, so yeah, which means minus 2 hours, which gives me 9 hours today, 11 hours tomorrow, and 11 hours in 2 days, which gives me 31, 20 plus 11, 31 hours. That's a lot. That is a lot. Yeah, I mean, I should get it done. 30, my goodness, 31 hours a lot. I'll be fine. I'll be fine. Yeah, it'll be fine. It'll be fine. But then, after, on the 1st of July, unfortunately not the 4th of July, it's, I'm sorry, I missed it, I'm so sorry, my lads. The 1st of July, for, hopefully from then on, I'll have more stuff coming. I would really like to turn this skip thing into a monthly thing, so that every month I would be making these big projects, except I will not be taking like 2 weeks in advance. Yeah, on the beginning I was planning to release it on the 13th of July, but then I realized that I would have to then go 4 weeks without uploading a single thing, and I realized that no, that is unrealistic for me. I cannot like spend 4 weeks without uploading videos, because that would be horrible. Oh my goodness, terrifying. So yeah. We could make it make it again. Make it into a month thing. Yeah, but I will make it into a month thing. I think yes. It should be fine. It should be great. It should be come on, it'll be fine. Yeah. Monthly thing already. Yeah, let's do it. I mean, I think it's very much doable because here's the thing, for those 2 weeks, next time I will be more prepared and I'll start the work on the next thing on the 1st of July. The day the skip is uploaded, I will start the work on the next thing right away. Yeah, should be fine. Alright. Monthly manic episode. I mean, better scheduled than not scheduled, right? I'm just saying. It's better if I have it in a calendar. I mean, I'm just saying. If I have it calendar, at least I know what it's gonna be. Yeah, it's good. I was thinking about remaking my upload schedule to have like, I don't know, a new video every 3rd day. Like a new short video every 3rd day. So for example, like abstraction of example, because abstraction of example is a very short, light, 5-minute long video. Every week I would make a big video, for example, like don't think or information or make it builds a weapon or abstraction. And every month I would make a larger video like skip, because that would seem fun. That would mean, you know, that I could make all kinds of videos. Because there are many topics, and I do mean like many topics which I cannot really make into these large videos, and there are many topics which I cannot really make into these short videos, so I would have to find some sort of balance where I could make both. I suppose that would be good enough. If I had an editor, oof, that would be easy. But I am stuck with Make It as my editor. Can you imagine? Teach me something each time. Well, I mean, yeah, that's good. It's good. Skip won't teach you a single thing, unfortunately. I was actually terrified when I posted, right, this thing, when I posted this thing, and you started guessing about yes over here, and I realized, oh my fucking god, holy fucking crap, I am a science channel, and what am I doing a non-scientific thing? It terrified me. I was terrified, I remember. So yeah, skip is very much non-scientific. Should you remember, it's pure entertainment, all about entertainment, not science. Science is not allowed here. So, no science allowed. For the monthly uploads, there will be no science allowed. Only fun. Only fun allowed. I am a fun channel. I'm not a nerd. We are here to... I am a gaming channel, so smash the like button, destroy the subscribe, devastate the bell, and yeah, exactly. Oh wow, that is not quite the convenience store I imagined. This is the geometry on this bit. Well, shall I say out of sorts? I freaking love getting entertained. Oh yeah, then you're gonna love the skip. It'll be like 10 minutes of entertainment, but some really good entertainment. It'll be really good entertainment. It should be really entertaining. Hopefully it'll be massive dose of entertainment. It'll be your monthly dose of entertainment right there. That is quite some creative geometry. Guns on trail looks super cool. It is, right? Oh, it's so much fun. I love this one. I love this scene. The gun. I just shot myself. It's funny because, you know, the clones. I have a cloning machine, that's why it's funny. That was really well. Oh yes. Oh, if 2 people said all at once that it was well done, that means it was really well done. Well then, just wait till you see more. You'll have to wait 3 days. Did I mention that it's not finished, by the way? Like the trailer is out, the release date is. I think the only person who released the release date for something without even starting the work. Premiere it. That's a good question. There is a reason why I don't think it will be able to be premiered, but it might be premiered. It's complex because I cannot even tell you what it is. You have to understand how much reserve it's taking to not babble about this, because it's difficult. It's difficult. It's a fun thing. I would like to listen. I would love to lower your expectations, but I just simply promised myself that I won't. Procrastination is a great. It is, though. It is. But can you imagine, by the way, that you are working on a project and the first step of that project is to release a release date? The first step is to tell you, okay, this is going to be out on the July 1st. That's the first, without knowing how long the recording is going to take, how long the effects are going to take, without anything. You just say, okay, this is going to be out on July 1st. Like, that was such a smart idea. That was so... To be fair, that did motivate me a lot. that was a good motivate. I should do that more often. That's why I love planning stuff for myself. Oh, one thing though. When it comes to, by the way, planning skip. When it comes to... This is a true story. I will end the stream now, but before I end the stream, I'll tell you a kind of snapshot to a story, about which I'll make an entire stream after the skip. All right. So after the skip premieres, when I'll make a stream explaining all the fun bits and how everything was, behind the scenes stuff like that, then I will tell the full story. But basically, I wrote the skip, right? I kind of planned the entire thing around 3 months ago. Before this 3 or 4 months ago, I did it before this channel even existed, during a mental breakdown. That is the level of fuck it, why not level of the skip. This is the I don't mean to sound like the cool kids say nowadays, but this is the fuck it we ball of the make it videos. That's what it is. That is the make it lost it all and is completely insane into the video. I knew I smelled the mental breakdown somewhere. Oh, it's always not 5. You keep looking. No, done. Stop me. It's actually very good. Yeah, if even that, it's a proof. You can always. You have to be mental to be a YouTuber. I mean, only a YouTuber. All right, let's be real. Only a YouTuber. Now that's mental. That is quite mental. Although that's actually, if the skip premieres and if it will be good. I don't know what I'm saying. If the skip, it will premiere. Unless someone offs me in the next 2 days, it will premiere. I will move heaven and earth and go battle gods by myself until it premieres. But it will be good, and that will be a really good proof that, you don't actually need resources to do stuff. Because this is made with no budget. None at all. This is made with non-budget and no crew, except for 3 scenes in which I had a friend of mine come over just so that they can hold the camera. That's it. Apart from that, every single thing was made by yours truly. Which, yeah, does lower the quality significantly, to be fair. But at the same time, it also lowers the production cost, which, as I said, I love money, so very convenient, handy dandy indeed. I feel like I should make podcasts sometimes. I know it's dangerous because podcasts elevate ego of one, of decrease. Yeah, if you make podcasts, then they are bound to elevate your ego. So that's very terrifying, slippery slope, which I am not going to start anytime soon. But I feel like most of my science live streams just descend into this madness of me just babbling about stuff. Like, for example, resistor codes. Have you ever seen resistor codes, the bands in the resistor? They are horrible. I mean, why would someone... What's the deal with airplane food, by the way? And on that note, I should end. I was supposed to end the stream 45 minutes ago! Okay, so I'm off to finish the skip, to also finish other stuff, you'll see. For now, that'll be it. Thank you so much, Ali and Ted, for being here. This is actually very well streamed. I will do more science streams from now on, and also I am done with GTAs. Oof, finally, feels good to say it. Thank you everyone so much for watching, and have a great day. Bye.